Welcome again to today's class. In today's video, we want to discuss another important experiment in physics. That is experiment on upthrust in a liquid. In this case, we want to discuss water as a liquid, so to speak. Now, it has the objective to determine the upthrust of a liquid, that is water. Apparatus, you see vernier caliper, a 250 ml beaker, weighing balance, metal blocks of different weights, thread, and what? Water. Look at the diagram. This is just beaker. This is talking about 2 ml what? Beaker. Okay? Then this is water at 150 ml, and this is 250 ml beaker. Okay? Let's see the procedure, so to speak. You are provided with an empty 250 ml beaker. Determine the internal diameter of the beaker. Look at the diameter. This is the circular part of the word beaker. So the diameter means like this. You have to get this distance. Okay? You have to get this distance. That is the diameter. Okay? They say determine the internal diameter of the beaker with the aid of the vernier caliper. So you have to mount the vernier caliper like this to get the word diameter, or you fix it inside such that it will get the word diameter. Just package it well. Then weigh the 250 ml empty beaker and record its mass as MO. Wow. So when you take your weighing balance, get the weight of the 250 ml beaker. As I check my own, I got 100.7 grams. So you check your own weight and see what it will give you. Actually, this should be taken as the mass. I got the mass. To get the weight, you divide it by 1000, then multiply it by 9.8. That will be the weight. This is just the mass you get with chemical balance or beam balance, etc. So when you get the mass in gram, divided by 1000, then it will go in kilogram, then multiply by 9.8, it will be in what? A note. That is the weight. Okay. Pour some water into the beaker to the point of depth HO of 150 ml. Wow. So the distance from here to here is HO. So as I pour the water now, they said weigh the beaker with the water content and record its total mass as M1. Now, because we want to perform this experiment without touching apparatus, as you have known the mass of the beaker, the implication is that mass of the beaker and water, mass of beaker and what? Water will be equals to, since the water is 150 ml, there are some conversions you need to note. One is that 1 ml is equal to 1 cm cube. 1 ml is equal to 1 cm cube, and is equal to 1 gram. Is equal to 1 gram. And so we are getting it this way because we said that density is equal to mass over volume, and mass is equal to density times volume. Density of water is 1, volume is 150. So 1 times 150. That means this 150 ml is equivalent to 150 gram of water. From density times volume equals to mass, and density of water is 1 gram per cm cube. So you multiply, it will be giving you 150 gram. So you call it 150 gram. That is it. You say that this 150 gram plus this will now be giving you 250.7 what? Gram. That is the mass of the beaker and water, and that 150 ml of water. Okay, weigh the beaker with the water content and record its total mass as M1. So we call it M1. Gently immerse completely the metal block mass X 20 gram into the water with the aid of a thread. Find the depth of the water, that is the height. So you measure the height of this water, the height of it, use your ruler to measure it. So as I measure it, I was getting 5.4 cm. The height of the 150 ml of water was giving me 5.4 cm. So that means two things are what you are to do. Weigh the what beaker to note the value, then get the height of the water to note the value, then you can go direct and do your manipulation without wasting your time anymore. Then they say find the depth of the water height h and find the change in depth of water h minus ho using a equals to pi d square over 4, where a is the cross sectional area in cm squared. Determine a and ah, where h is the depth of water in the what beaker. Repeat the procedure with x equals to 30, 40, 50 something gram respectively, and determine accurately the corresponding depth h of the water and ah. Tabulate your readings. This is just trying to tell you that as you are seeing this like this, as you are seeing this water here, when you immerse 20 gram, it will displace its own weight inside this water, and as it's displacing its own weight inside this water, the volume of water will increase. That is just point number one. Then when you also do the one of 30, 40, 50, the height will be increasing, and that is the concept of this what experiment. Okay, we have succeeded to get the mass of the empty beaker to be 100.7 gram. So two things are what you just need: the mass of empty beaker and the height of the what 150 ml water given to you. Are you getting it? And so next they say we should get the mass of the empty beaker with water, and we say it's 250.7 gram. As far as we have gotten the empty beaker, we will tell them that since we are talking about water, density of water is 1 gram per cm cube. We now tell them that density times volume is equal to mass. So 1 gram per cm cube times 150 cm cube, which is equivalent to 150 ml, that will be giving you 150 gram. So 150 gram plus this will be giving you 250.7 gram. So you achieve that. The height is 5.4 cm. That is the height. Now, what we need to do again is, you recall from mensuration of solid shapes that when you have a cylinder, volume of a cylinder is equal to base area of that cylinder times height. So we tell them that this water we talk about, they have given us the volume of water to be 150 ml, and we have gotten the height of that water. And this water takes the same base with the base of the cylinder. They take the same base. And so what we say is, we say volume is equal to pi d square over 4 times height. This is because volume of any solid shape is equal to base area times height. You know that how we got this formula is that this is in a circle. The base of that beaker is in circular form, and every circle has area to be pi r squared. That is area of a what? A circle. But because they expect us to get the diameter, we remember that r is equal to d over 2, and putting it here, it will now be pi d square over 4. That is how we got this area. So base area times height is equivalent to volume. So once we have gotten the height of that volume, we can get the area. We now tell them that 150 is equal to the area times what? 5.4 cm we got. Therefore, the area of this what? Base will be equal to 150 over 5.4. We say 150 ml is equal to 150 cm cube. because 1 mil is 1 cm cube. So when you compute this with your calculator, we have 150 divided by 5.4. That will be giving you 27.8 cm cube. That is the area. Yes, that means we have gotten the area of the what? Of the what? The base, which we said the base of the water is the same thing with the base of the container, because water takes the volume of the what? I mean, it takes the shape of the what container is inside. Now we have gotten our area to be this. Now they say we should get our d. We tell them that pi d square all over 4 is equal to 27.8 cm cube. Making d square subject of formula. Therefore, we say that d will be equal to, as you are seeing it here, we say that pi d square is equal to 27.8 times 4. D square is equal to 27.8 times 4 all over pi. Right? Yes. And so we also say that d will be equal to square root of 27.8 times 4 all over what? Pi. Okay. So that means what we'll be writing there is square root bracket 27.8 times 4 divided by bracket what? Pi. That will be giving you approximately what? 6 cm. So that means the diameter of the what? Of the beaker is 6 cm. So we also note it. We say the diameter is 6 cm. Our MO is equal to 100.7 gram. Our MO1 is equal to 250.7 gram. Our area is equal to 27.8 cm squared. Area is in squared, please. Yes, we have gotten the parameter. The volume is constant. Okay, the HO is equal to 5.4 cm. Wow, we have written down all those parameters. So the area is constant. We'll write it here. 27.80, 27.80, 27.80, 27.80, 27.80. Okay? Then the height, this is H. We have to look for it. Then our HO is 5.4. We have to have it in our mind. Your temple is the body of Christ. Now, we noted that density of any substance is equal to mass of that substance all over the volume of it. The volume of that substance is equal to mass over density. Now, what substance are we talking about? In this video, we are talking about steel. In most labs, steel is what we use as our mass. The mass comes in terms of steel. And so the density of steel is between 7.775 to what? 8.05 gram per cm cube. That is density of steel. And so we just take, let's say we just take 8.05 as our density. We now say that This volume is equal to mass over density. Now, when you are talking about steel and you are not able to get the volume of that steel, what it simply means is that put that steel inside water. When you put it inside water, take note of the increase in height. Look at the initial height. So this one is the height you will get when you put it inside water. Now, that means the steel displaces its own weight in that water by increasing the volume of that water. And so to get the weight or the mass of the water it displaced, we will say this height minus this HO. We will get the height it displaced, height of the water is displaced. The height of the water is displaced times the volume of that what beaker or the volume of the water will be giving you the volume of that what of that steel, so to speak. And so we say volume of that steel will be equals to the height, the final height it will get when you put the steel inside and it displaces its own weight, minus the original height of that water before you put the steel inside, times the area of the what of the base, which is same with area of the water or area of the beaker, of the base of the beaker. And so bringing this down, we'll be having that mass over density, mass over density times what? Area, plus this go this side, HO is equals to H. So we say that HO plus mass bracket area times density is equal to that height. That means if I say 5.4 plus 20 all over 27.8 times density 8.05. Once I compute this, it will give me the height we will get when you put 20 cm of that, when you put 20 gram of that mass, when you put 20 gram of that steel inside this water, it will give you the increase in height. I mean this final height. It will displace its own weight and increase the volume of water to that height. That height it will get is what we get from this. So we now tell them that therefore height is equal to this. So we press it in our calculator. We say 20 divided by bracket 27.8 times 8.05 plus 5.4. That will be giving you 5.48936 continue. And that is in centimeter. Now, because you can't get this with your what? Meter rule. Reading accuracy of meter rule is 0.1 cm or 0.0 like 0.1 cm or 0.1 cm. That means what you can get is 0.1 cm. That is reading accuracy of the meter rule. Now that means what you have here, you have to be approximated to one decimal place. That will be giving you 5.5 approximately. You write it here, 5.50. Then you do same by putting 30 here. You put 30. You say 30 divided by bracket 27.8 times 8.05. That will be giving you then plus 5.4. You will be getting 5.534. 5.5340 continue. Now, because we cannot get this with our meter rule, centimeter rule, we can say let us approximate it to 5.55. We have here 5.55. Because we can get 5.5, 5.6, and in between 5.5 and 5.6, that is 5.55. Okay, we change here to 40. 40 divided by bracket 27.8 times 8.05 plus 5.4, 5.578. This will give you 5.5787. Wow, we approximate it to 5.6. Then we go again. We change it to what? 50. We say 50 divided by bracket 27.8 times 8.05. We have then we 50 divided by bracket 27.8 times 8.05. We'll be having, okay, plus 5.4. We'll be having 5.623 for continue. So we can't get 5.6234. So we approximate it to what? 5.65. Just round it up to what you can get. Then you get the one of 70. Change here to 70. 70 divided by bracket 27.8 times 8.05 plus 5.4, 5.71. We approximate it to 5.70. We have gotten our height. Now we have gotten this and we have gotten this. We subtract this minus this will be giving me 0.10. This minus this 0.15. This minus this 0.20, 0.25, 0.30. Stay in cm. AH means multiply A with H. We have 27.8 times 5.5. That will be giving you 152.90. We now also say times 5. That will be giving you 154.29. Then multiplying again by what? By C0, it will give you 155.68. Multiply this with this 65. 157.07. Then 70. Multiplying 5.70, we'll be having 158.46. And so with this approach, you have gotten your table for this experiment. Just note the mass of the empty beaker, that is 1, and note the height of the water, that is 2. You are good to go to do your manipulation. We have gotten our table of value. The unit of AH is cm cube. cm cube, area times height, cm cube. Okay, so next is for us to plot the graphs and answer questions that will follow it up. Okay, so don't forget that as every experiment you have to write the precautions that follow it, and one of it is for this one, error due to parallels. You have to be very careful with that because you are trying to measure out the distance from here to here, so error can occur due to parallels. Parallels error can come up here. Are you getting it? Then as you are measuring this height of water displaced, error can also come in there. So error due to parallels is avoided or is taken care of by taking my reading vertically downwards on the meter rule. You say the error you try to what? Avoid, and how you avoided it by taking my reading vertically downwards on the meter rule. Another error you should take note of, another precaution you should take note of is while trying to immerse that mass inside the water, ensure care was taken while immersing the mass inside the water by ensuring that it did not touch, or it doesn't touch the side of the beaker, and also that it does not splash water out, so as to what enhance accuracy. Okay, so try to include your precautions while you are done with every experiment, whether they ask you to do so or whether they didn't ask you to do so. Don't forget that. Thank you for watching this part. Let's go into graph plotting. Okay, let's see how to plot this graph. This is table of the values for the experiment. Now, the instruction is plot a graph of S against AH. Please, first of all, write the date. The title is a graph of X, which is the mass, against what? AH, which is a CMQ. Remember, this is not the standard graph you know. This is just a sketch of the graph. Now, look at this X. Label your Cartesian axis. Call this your X in gram, and call this your AHACM. Now we have this from 20 to 70. If we say 0 here, 10, 20, 30, 40, 50, 60. Wow, it didn't reach 70. I can decide not to start from 0,0 for Y. I can start with 10. Here 10. I will still know what we would get for X. So that I will not be using 0,0 unless it is specified or instructed. So 10, 20, 30, 40, 50, 60, 70. If you have been following our videos on practicals, you will see why we do that. It's because it is not instructed. They just say plot graph of S again. This minus this is 10, this minus this is 10, 10. So it go well. Now for horizontal axis, start from 152.9 to 158. So if we start from 0, 0, it will not go well for that horizontal. Yes. And so we can say let our horizontal, we can say let our horizontal be what? 152, 153, 154, 155, 151. Okay, let our horizontal be 150 what? 2. And let our vertical be what? 10. This is for X and this is for Y. So this 10 means from here up. 152 means from here down. So 152 here, 153, 154, 155, 156, 157, 158, and 159. Okay? Now, you see, it's not all the time we will say 0,0. That is just a point we have to emphasize here. 20 against 153. 152.9 approximated to 153. 20. Then 30 against 154. Approximated answer. Approximated answer. 40 against 156. Approximated answer. We are using approximation to nearest whole number. Then 50 against 157. Then 70 against 158. Okay? So we have located our points. We have succeeded to locate our points. Next is to locate our line of best fit. Yes, we have succeeded to locate our line of best fit. Remember, We plotted 20 against 153 approximately, then 30 against 154 approximately, 40 against 155, 155.68. We decided to put it here because look at 155. Half of 155 is 155.5. So we just put it here because this number they are big enough, unlike these ones, unlike that 29. Then 50 against 157. Then 70 against 158.5. 158.5. Then the next thing we have to do is we get the line, we get the slope. Okay, change in what? X is equal to, here is about 62. We say 62 minus, because this is 60 and this is 70, so here about 61 or 62. Then here about 20 all over, we get the change in AH. Here is 158 minus, then here is about more than half. So we can say 152.5, 152.6 or 152.7. So we can say 152.7. Are you getting it? And so we have this. We now say that our slope equals to change in X all over change in AH equals to 62 minus 20, 42 all over. This minus this will be giving you 158 minus 152.7, 5.3. So our slope will now be equals to 42 divided by 5.3. That is 7.925 gram per cm. Remember, in the starting part of the video, we said that the range, the slope of, or the density of steel ranges from 7.75 to what? 8.05 gram per cm. So you now see that this will be taken to be the density of that word steel. Yes, using the principle of the mass of water is displaced, or the volume of water is displaced, or height of water is displaced. So we just use the principle of the height of water is displaced to get the density of that what steel, or that substance add or which was immersed inside the water. So that is for this. This will be taken to be the density of the steel, or density of the substance put inside the water. Don't forget to write your scale. In x axis, that is x in gram axis, we say 2 cm represents 10 gram. In AH axis, we say 2 cm represents what? 2 cm represent this minus this 1 cm cube. So note it. Remember we say this s axis is talking about vertical. That means all these variables, all these are called variables. It's not you coming to say in y axis. Here is not y axis but s axis. Have it to your mind. Now look at the question. Determine given that the density of water is 1 gram per cm cube and that of solid is 10 gram per cm cube, that means the upthrust and tension in the thread for 20 gram. Now, there are formula you need to note. One is that density of water all over density of the substance, density of the equals to upthrust in water divided by G all over mass of the substance in air. Upthrust is a weight, and so divided by by G, you get its mass. And so making upthrust in water divided by G subject to formula, we have that upthrust in water divided by G is equals to density of the substance in air, density of water, which is 1. Density of water is 1. Density of the substance is given to us to be what? 10. Then times mass of substance in air times 20 gram equals to this. But this is in gram now. This is acceleration due to gravity. I want to put it in 9.8. Now, because I put this in 9.8, I have to convert this gram to what? Kilogram. This is 20 gram. Convert it to kilogram. Okay? Then it means I can now use this 9.8. Therefore, upthrust in water will be equal to 1 over 10 times 20 over 100 times 9.8. So when you compute this, you'll be having 0.01962 Newton. 0.01962 Newton. Are you getting it? That is the upthrust in water. Now, what will be the tension in the thread? What will the tension be as? We remember that tension is equals to weight of that substance in air minus upthrust in water. Upthrust in water. And weight of the substance in air is 20 over 1000. 20 gram, weight of it is 20 over 1000 times 9.8. Then minus upthrust in water, 0.01962. So it means compute this. If you compute this, minus it with this 0.01962. When you minus it, you'll be having the tension to be equal to this times this minus it. That is 0.17658 Newton. So the tension will be 0.17658 Newton. That is by calculation. Approximately, it will be giving you 0.18 Newton. 0.18 Newton, whereas the upthrust approximately will be equal to 0.020 Newton approximately. Are you getting it? So that is how to run this experiment without touching apparatus. Thank you once again for watching today's video. Please don't forget to click like, subscribe. Just subscribe. Use it to appreciate my good work. Okay? If you find this video interesting, use it to appreciate me. I appreciate so much. So click subscribe for me. Turn your notification button on. Then click like button. Share to your friends. You can comment. Maybe appreciate the work or ask your questions. Okay? Thank you for watching today's video. See you in the next video.